Hello, and welcome to this tutorial on object pooling. So this is a scripting tutorial, and this is really aimed at sort of intermediate kind of level scripters. So I'm going to assume that you are using advanced mode in Crayta and that you already have some experience in a bit of scripting here and there. So you may have dabbled in writing a couple of scripts for Crayta. You might have some experience in other game development languages and other APIs. You're coming into Crayta and you're wondering how to do this particular programming paradigm, object pooling. But I'm going to assume that you can follow along with some of the scripting stuff that I'm going to be doing, so that and if at any point you get stuck or you're not sure about something, then you can pause the video and just read through the code that I'm writing and make sure it makes sense to you. And if at any point you get stuck and you've tried that and it didn't work, then feel free to log on to our Discord where I am, and tag me in a question, and I will answer you and see if I can help out with what you're stuck with. Additionally, in the Discord, there's loads of game developers in there who are all playing around with Crayta and Lua and scripting different things. So there'll be lots of people on hand to help. And there's also the community tab. There is some packages out there I've seen that do object pooling, and one or two of them do it really, really well. So if this is a concept that you're interested in, but you don't want to do the scripting, but you want to leverage what I'm talking about, then other people have already made some great packages. So go and check those out. But if you do want object pooling, scripting knowledge, and why and how and when to use it, then please stay tuned for this tutorial. So I'm just going to get my notes. Okay, so object pooling, what is it? So let's start with this game here. Now this game is a bullet hell game, which means that some tennis balls get fired out of this dummy here continuously every 0.2 seconds. And that's okay, but one thing to be aware of is that if I open up my performance tab here, I'm gradually filling up this bar here. Okay, so this is a bit dangerous because the more entities I make, the more memory my game is using. So I will just pause that and explain a little bit more about that. So every time you spawn an entity in your game in Crayta, you're asking Crayta to go and grab some available memory for you, and so that you can use it to store that entity. So you're saying, I want some memory for this tennis ball. And Crayta goes, absolutely, here you go. And then you want to spawn another one. So you say again, I want some more memory. And you continuously do that, especially if you're repeatedly spawning things like that. You're asking Crayta again and again and again, you're saying more memory, more memory, more memory. The sad thing is that memory is finite, and that doesn't matter what level of computer you're on. The Stadia and the Crayta computers are incredible machines, but it could be the best supercomputer in the world. It still would hit a memory ceiling where you ask for more memory and it's at capacity because you have millions of tennis balls and you haven't released the memory for any of them. So that's one of the main reasons we're going to be using object pooling, is to avoid continuously asking for memory and filling up our memory with tennis balls. And the other reason is every time you ask for some more memory to be allocated to an entity in your game in Crayta, that's quite a computational thing to do. Go and find out where that memory is and then give it a register address and blah, 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 right? So that's actually computationally expensive. And in runtime, in a game, we want to reduce how much computationally expensive things we're asking the CPU to do. We want to improve the performance of our game. We want to keep it smooth and not jerky, which is the same as smooth. But we basically want to avoid computational things if possible. And object pooling is a way to control the amount of memory that we're using and a way to avoid constantly allocating memory and deallocating memory when you destroy things. So that's the other side of things. You might be fine with asking for lots and lots of memory because you're like, don't worry, it's going to get destroyed, and then the garbage collector will come and pick up all of that available memory and it will reuse it. which is okay. But again, you're still there's still the computational part of it, of allocating and deallocating memory, which has a bit of a CPU overhead that you just want to try and avoid, if at all possible, at runtime when you're in a game. So, and this gets worse for more complex entities as well. So at the moment, I'm spawning this sports ball here, and you can see it's a mesh, and it's got a trail as well. So mesh, and it's got an effect. So it's actually spawning two things whenever I spawn that one template. So it's got to store the template and the mesh and the effect. And the more complex thing that you're continuously spawning, the quicker your that yellow bar is going to fill up, but also the bigger impact on performance it's going to have on your game. So a really good reason to use object pooling. So if you are just spawning one or two entities occasionally, then you may not need to use object pooling. But if, like me, you're creating a bullet hell game and you want to shoot meshes at the player, then you're going to need to use object pooling. And so object pooling is essentially a programming pattern. And what it is the idea is to create a bank of objects, and then to grab one of those objects and use it in the to fire at the player. And then when it has expired for whatever reason, put it back in the pool, and then grab it again and reuse it again. So you've got a pool of objects, pool of entities in your game that are created once at the beginning, and you're going to grab one of those entities, fire it at the player. Eventually, for some reason, it will decease and then go back in the pool. Okay, and so we're recycling the same objects. We're not allocating and deallocating memory all the time at runtime. We're doing it once. We're allocating it once at the beginning, or whenever it's needed once, and then using that same thing over and over and over again. So recycling that entity. Okay, so the idea, yeah. So basically, we're reducing the memory overhead, and we're reducing the CPU overhead in allocating and deallocating all the memory. So how do we implement this? Well, let's have a look. So I've got a ball spawner script here. Don't worry too much about some of the stuff in here. The main thing we want to focus on is this line here, line 32, which says local ball equals get world spawn, and then it's spawning whatever is in the ball template property at position 0, at rotation 0, and then here I set position and I shoot the ball at the player and blah, 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 blah. But this line 32, this is the key moment where this is actually asking quite a lot from Crayta. It's saying, go and get me some memory and stick a ball in the memory, and then let me manipulate that memory for the rest of the game. And I'm going to do this again in 0.2 seconds. Thank you. So that's the line of code that's in question. Now, to start object pooling, we need to actually start at the end. So how are we going to know when this tennis ball is done? There's a couple of different ways you can do that. One of them might be an event. So it might be if it collides with something, that could be a way that you know it's done. For this game, I'm just going to give them a lifespan. So I'm going to do that by adding a script to my sports ball. So sports ball template, entity add script, new script, and this is going to be called ball pool member, because this is going to be a member of my ball pool. And I'm going to edit that. And here I'm going to create a property called lifespan. It's going to be a number. The tooltip is going to say length of time in seconds to keep this entity alive. And the default for that is going to be 2 seconds. Okay. Now I'm just going to set up a timer so that after its lifespan, it will do something. So let's set up a timer real quick. Self.remaining. In the init function, I'm going to do self.remaining, get hold of that lifespan there. And then I'm going to add my onTick function. And in here, I'm going to need delta time. So that's passed automatically by Crayta, which is the amount of time since the last time onTick was called. And using that, we can actually run timed things. So self.remaining equals self.remaining minus delta time. Okay, so now this is a countdown. We have this countdown which starts at 2, and then every tick it reduces. Let's also have a state here. Let's say we're alive at the start, and let's only do this countdown if we're alive. And if we run out of time, so if we hit the end of our lifespan, then we can set alive to false. Okay, so we've got some sort of, this is kind of metadata going on behind the scenes, which is basically managing the state of this tennis ball. And it's basically saying if it's alive, set it to alive at the start. If it's alive, count down, and then when it gets to 0, set it to not alive. And actually, one of the issues that I've created here is there is no way for me to reset this state if I grab that. So in the future, I'm going to be grabbing this ball out of this pool and reusing it. So at that point, we won't be able to set it to alive again. So let's create a couple of functions which we can use to manage the state of this. So one of them is going to be the set state function, and that's going to set whether we're alive or not. And one of them is going to be the get state function. And that's just literally going to return whether we're alive. And the set state function, to start with, just sets that we're alive or not. If we are alive, then we want to restart the timer. Okay. So now here, instead of this, we will do self set state, and we will set our state to true. Okay, so we've just changed the code a little bit. So now we have this set state function, which means we can actually activate that from outside of this class, which we're going to need to do in our ball spawner. And we also don't need to call the init function again. So if we do other setup things here in our init function, then they won't impact the state. So we're keeping the state slightly separate there. Right, so we need to do some other things in this set state. We need to say self.visible is equal to whether it's alive. So if it's not alive, it becomes invisible. Like the spelling of visible there, pretty spelling. There you go. Self.visible equals alive. Let's also do self.collision enabled equals alive. And let's do self.active is alive. So collision enabled is going to be if we have a physical body on a mesh or a voxel mesh, and active is going to be on something like a sound or an effect which is playing. So turn those on or off depending on whether the state is on or off. Problem with those two is they are specific to different entities. So I'm basically making this a bit more reusable, because at the moment this is just attached to a mesh, but I might want to attach this to an effect or a sound or whatever. So let's check whether we've got those properties before we do that. Self.collision enabled. If self.collision enabled is not equal to nil, notice I'm not asking whether it's just exists. Like I'm not asking whether it's true or false. I'm asking if it's nil, which is different from true or false. So if it's not nil, then we have either true or false in there. And same with active. The nil, then end tagged. There. Okay, self.active. The other thing we need to do here is actually do that with our children as well, because this could be a complex object with lots and lots of children, all of which will need turning invisible and turning off collisions and all of that sort of stuff. So we need to do that in a loop, and we need to separate this into its own thing. do that now. So function, all pool member, and let's do toggle entity. And let's do entity and on. Toggle entity. So then we'll grab this, paste that in there. Self.visible was never going to work. These are never going to work because they were always going to be, so they needed to be self get entity dot visible and so on. But it's actually kind of handy that I've done self dot, because now I'm just going to replace that with E, which is the name of the entity, and then I will pass self get entity like that. Okay. And then we need to call that self toggle entity, self get entity, on is alive or not alive. Okay. So that's toggling us on or off. Let's do that with our children as well. So let's get hold of the children first. Equals self get entity get children, and I've done 2 get entities here. So I'm actually going to just store entity as a local variable here. So I'm trying to reduce the number of function calls. Okay, so get hold of the entity, pass it to that thing. Get hold of the children, loop through the children. This is how you loop through table in Lua. And for each child, we want to toggle entity. We want it to be that child, and we want it to be whether we're alive or not. Okay. So now we are setting the state, and the state of our object, alive or dead, is tied in with whether it's visible, whether it's got collisions, whether it's active if it's an effect or a sound. And that happens after our lifespan of 2 seconds. Now, we don't actually need to do anything in Ball Spawner to test this. We'll just test it, and we should see. Let's turn on the console. We should see that we have an error. Line 36, get children. That needs to be a capital C. The children. The children need a capital C, Andy. That's what they need. Okay, it's spawning, and it's still not dying. They should be not there after 2 seconds. I wonder why that is. Could be to do with this. Yes, in our onTick method, we are setting alive to false, but actually we need to set the state now. Self set state to false, not just alive. Hopefully this works. Let's find out. Come on. No. Still not quite happy. I wonder why that is. Is it calling that? Let's just see if it's getting to this point. Print, toggling, and then let's get the name of whatever this is that we're toggling. Let's just see if the timer and everything is working. If it's getting to that point, then. Okay, so it's working. It's actually trying to toggle those things. Toggling them on. we should see some of them come up true. Some of them come up false after 2 seconds. Yeah, we got some falses. So, E dot visible. Oh, I've set it to alive. This needs to be on. Okay, cool. It doesn't know what alive is, but it didn't have an error. Interesting. That's fine. Ah, we might need to do that for all of the children of the children. Let's put that there as well. Let's loop through the children of the children. Nearly fell for it twice then. You get children. Yeah, okay. Actually, now we just need to do... So we're only doing that once. There. So we should see them disappear after 2 seconds now. Yay, okay, cool. So they're disappearing after 2 seconds, but if I click on the performance tab, we're still generating new ones. So whilst we're being good for stopping us needing to simulate those things that have already perished, we don't need to simulate them anymore, so we're reducing the CPU overhead just a little bit, but we still are allocating loads of memory, and we will run out of that memory at some point. So we haven't actually done our object pooling yet. All we've done is add a lifespan to our ball pool member, because it needs a way of turning from alive to deceased, or turning it from on and running around our game to off and hidden and awaiting to be reused. So we have that second part of it now. So let's go and make the first part. So in here, we've got ball equals get world spawn, which is not good. What we need to do is create a ball pool at the start here. So that's going to be an array, which is going to store a lot of the sports ball entities. So we're going to generate in a for loop for index equals 1 to 20. We're going to generate a bunch of instances of that template. Let's actually just get hold of this. I want to keep that there because I want to make sure I finish that. And then add that to our ball pool. So table.insert self.ballpool all. Okay, good. And we're going to insert that there. Now we have a bank of 20 balls. We just need to write a function to get hold of one of them. So function ball spawner get ball, and this is going to return a ball. So we're just going to loop through that for index child in self.ballpool. Loop through all of those balls. If child reference the ball pool member script. Get state. Did I create a get state? I feel like I did. Yes, here. Let's put that near the set state. That doesn't make any sense. If that, then so this is going to get if it's alive. So I want if it's not alive. So not that. Yeah. Okay. If not alive, then that's our ball. So return child. And then here we're going to return nil. If we get to this point, we've run out of balls that are available, and so we can't get another one. So I'll show you in a minute what to do in that situation, but for now we're going to return nil. And here we're going to do self get ball. And there we go. Let's run that. See if that worked. Whoa, loads at the start. But that's because when they're spawned, they're doing that thing. Attempt to call table value line 54. Let's find out. Line 54 is that. I pairs. Try that again. Okay, so an explosion of tennis balls at the start. And then, aha, they are not visible. Now this is because I have not set the state back to true. So state is set to true on the init function, which is why we're getting that explosion of tennis balls, because they're automatically turned on when we generate them. And then we're not, and then they're alive for 2 seconds, then they're turning off. In our set state alive, we're setting it to false after 2 seconds here. And then we never turn it back on when we get hold of them. So we need to go and do that. So in here, before we return child, we're going to do child.ballpool member set state. And we're going to set it to true. So we're reinvigorating those that child. We're returning here, which means that we'll only run this until we get one of these. And then once we get one, then we will no longer be running this for loop, which is exactly right. In here, we don't want to start true. We want to start false. We want to start hidden behind the scenes, awaiting the ball spawner script. Okay, so now it's firing them, which is really good. Performance-wise, we have 242 things in our game world. Now, it's a little bit more than I thought it would be, but that's because the other dummies all have ball spawner scripts associated with them as well, which means they're all generating those 20 things. So, now that we have that, what happens if... Yeah, what happens if we make it so that the lifespan of the ball is longer? Let's say it reaches the other end of the court. Hopefully 20 is enough. Okay, so now we're getting an error. Attempt to index local ball a nil value. Oh no. That was unexpected, but it was kind of expected because we get to this point where we reset our child. Where's our get ball? That's on the ball spawner. Here. We're getting to this point now. We're running out of things. So an easy thing to do would be to make this a property and say, here, we could say name equals ball size. Type equals number, default equals, we know 20 is not enough, so we could do 50. And then we would use, instead of that, we'd do self.properties.poolSize. Okay? Yeah, totally doable. We can do that. And now I can adjust the size. So if I find that I'm hitting that nil error, I'm running out, then I can increase our pool size. And that's fine. We can hard code it like that. We know that there's a maximum number of things that I can get hold of, and we can tweak it as well if we find that we don't have enough. Notice with the performance now I'm simulating 602 things, so I'm making 602 things. And that's including stuff that's just been made because scripts are there behind the scenes. So is that a bit dodgy? Yes, that could result, maybe we use this dummy target template, and it could result in us creating so many balls even that aren't being used. So a more efficient way to do this might be actually, this is one way, and this is a totally legitimate way you can do it. This will work, and you could be really happy with this, and most scenarios this kind of thing will work. You might also want to do the next step, which is a more dynamic form of array. And I'll show you what I mean. So in our get ball, so we what we do is we remove this stuff here. We take the creation of our array and we say if self.ballpool is nil, then we create our array here. Okay, then we check through our array, because if it wasn't nil, then we might have a child we can use. Then, if we haven't got a child at this point, so let's create a Boolean, a local Boolean called found ball. And it's false. And let's create a thing to hold our ball. And this is going to be there, like that. And instead of returning nil, we will return ball. Okay, stay with me. So here, we're going to get rid of that. We're going to do found ball. If we got to this point, we found our ball. And then if we never found our ball, so we reached the end of that array, and we never found our ball. We cycle through the array, we reach the end of it, and we still have not found ball. Then let's spawn one here. Okay, so let's do that. Let's do both of those. So now we're going to grab those, delete that, and put that there. And just delete this because we're not going to redefine it. We're going to use the same ball there. Ball equals, and we're spawning it, and then we're inserting it into our table. So what we're doing is creating the array if we need to. Then we loop through the array because it might have already existed. We can optimize this further. We can totally else. We can do an else there, because if we've just created the array, we know that there won't be anything in it. So we'll have to spawn our ball. If we haven't just created our array, then there might be something in it, and we can do that. Okay, so let's have a look whether that new way works. Let's see. So now we're generating more entities. They're not showing up, but we're creating them. And I wonder if we'll get to the point where it maxes out. No, because they're all not being set to on. So let's turn them all on. So ball, set state. At this point, we know we have a ball. And let's turn it on. Okay, we've got an error. Attempt, yeah, you can't just you can't just assume it knows what that means. Ball pool member set state. I need to reference the script that function is attached to. Of course. Too long using JavaScript. Okay. There. Okay. So now their lifespan is 5 seconds, and we're still making new ones. We shouldn't be making new ones. Let's go back to our script. We shouldn't be getting to this point. It should have worked anyway. Maybe it's this else. Ball false, ball equals null. otherwise create it? Ah, yes, we don't create them. Ah, okay. Let's these these variables, local variables, actually need to be at the start. There we go. Right. So the problem was I was trying that they were scoped into this else because I'd magically put that if else statement in there, which meant that ball and found ball didn't exist past that else, which meant this was going to struggle. Hopefully, that was the issue. Let's find out. Yeah, because it wouldn't have been able to use found ball at all. The problem was with the performance, right? It was continuously spawning. There we go. Okay, so we've capped at 52. So I was lucky with the 50 number before. But notice that I now have 52 and not 608, which is much, much better because this is now a dynamic object pool, which means it will never run out. It could overload, technically possible to overload. So there's a real trade-off between... let's stop that. There's a trade-off between the amount of control you have over the memory in your game and how responsive your game is. So if you want the possibility that there might be lots and lots and lots of things, then and you don't know how many there are, then you might want to make your object pool dynamic. If you want to control how many entities there are in your game and you think there should be a limit of 30 tennis balls before we reusing them, then that's totally fine. And that's another way of doing it and a little bit more control over the stuff there. You could also do you could also look for the one that's been like alive the longest. So rather than doing a lifespan, you just count up how long it's been alive, and then the one that's been alive the longest, you grab that, and that gets recycled. So that's another way of doing it. There's lots of different ways of managing your object pool, and what I'm trying to say is that there isn't necessarily any hard and fast rules to the right or wrong way to manage your object pool. It really depends on what you're doing with those objects or those entities, what you need them for in your game. Are they an effect or are they crucial to the core gameplay? It really depends on a couple of those different factors, but hopefully this tutorial has guided you through a way on adding object pooling to your game to avoid using spawn and destroy when you're creating and destroying lots and lots of things all at once. Remember, there's a limited amount of memory, even on amazingly amazing machines, there's a limited amount of memory. And there's also a limited amount of CPU bandwidth. And so the overhead required to create and destroy entities at runtime can sometimes cause problems in your game. So it's worth bearing in mind memory and CPU when you're creating a game. Ultimately, a game is like a real-time data model, which you're constantly changing everything. So you need it to be as fast as possible. And this object pooling is a way of speeding that up. Now, hopefully you didn't get too stuck. And if you did get stuck, please feel free to join the Discord and fire some messages or some questions into the Lua Help channel or at me. And if you didn't get stuck and you make something awesome, do that as well, but show us what you made. And I really look forward to playing your bullet hell games now that I've shown you how to do object pooling. And I look forward to, seeing you in the game.